All right, guys, so our last one that we're going to work together from section 2.6 is number 8. And I have my paper here because it's a little bit longer, and we're going to, we're not going to use the graph. We're going to work this out algebraically. So it's asking us to solve for x, and it gives us 1 over x plus 6 is greater than or equal to 3 divided by x minus 2. Now, this is what we would refer to as a rational inequality. And to solve this, we still want to get 0 on one side. So I'm going to begin by bringing everything to the left-hand side. So that will leave me with 1 over x plus 6 minus 3 over x minus 2 is greater than or equal to 0. Now, what I want to do is combine this so that I have one expression here. And the way that I combine my rational expressions is by multiplying that way. So 1 times x minus 2 leaves me with x minus 2. Drop down that minus sign, open parentheses, multiply this way. 3 times x plus 6, that would give me 3x plus 18. And then for my denominator, I multiply straight across, but I'm not really going to expand that. I'm going to leave that in factored form, and I'm going to leave them over there greater than or equal to 0. Now, what we want to do at this point is combine like terms in my numerator. So in my numerator, I see I have an x minus 3x, and let's leave a space so it doesn't look so jumbled. So that leaves me with a negative 2x, then a negative 2 minus a positive 18, or negative 2 minus 18 leaves me with a negative 20 divided by x minus 2, and x plus 6 is greater than or equal to 0. All right, so what I want to do again, take this a bit further, I want to find, and let me back up and explain why I'm going to do what I'm going to do. If you remember on the last example, I told you that we want to find the places where this function is equal to 0. In other words, my x-intercepts. And I also want to find where this function is undefined. So to find where it's undefined, we typically take that factored form in the denominator and set it equal to 0. That is factored, so that's set up. It's waiting for me to do that. But in my numerator, I don't have it in factored form yet. But I want to get it there, so what I'm going to do is factor out my GCF, my greatest common factor, and that will leave me with x plus 10. Then my denominator, I have x minus 2 and x plus 6 greater than or equal to 0. So again, I don't have my graph. Let's see if I can move my camera down just a bit. There we go. So we're not going to refer to the camera, but I still need those x-intercepts. So I'm going to use x equals negative 10, and where my function is undefined, which is at x equals 2 and negative 6. So I'm going to use these values, and we are going to put these values on a number line, and I want to make sure I have plenty of room to do this. So let's put this, where can I go? As high as I can go. Let's put a number line here. Okay. We're going to put these in order. So negative 10 might be down there somewhere. Then I might have negative 6 somewhere there. Then I might have positive 2 somewhere there. So what we're going to do is take my number line, and I'm going to break it up into intervals. And I'm going to test each one of these intervals to see where, and I'm going to refer to this expression here. I want to see where this function is greater than or equal to 0. Well, I know at that point right there, I know that x is equal to 0 at that point. Here it is undefined. I'm going to put undefined. That is a D, undefined. And there it is undefined. So I know that these 2 points will not be included in the the set and the solution set, whereas that one will, because 0 is included, right? There's an equal to part. But I've also got to figure out where this function is greater than 0. Where is it positive? Are my values positive here, 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 or here? It could be all of them, it could be none of them, or just some of them. So we have to test each one of these intervals to see where this function is positive. So it doesn't matter what numbers you choose, just pick a number within each interval. So this interval here is from, maybe I can put this here. We're going to test from negative infinity to negative 10. We're going to test that interval. Any number on this interval, so I can let x be equal to negative 11. So we're going to take negative 11 and I'm going to substitute it into this function. Now mind you, I'm not actually going to multiply the numbers. I'm just going to look at the signs of the numbers, because if the sign's positive, it works. It's greater than 0. If it's negative, then it's not greater than 0, right? So I just want to know, is my product positive or negative? So how do I do that? I have a negative 2, so watch me. I have a negative 2 times, what do I get when I substitute negative 11 into here? A negative 11 plus 10 gives me negative 1. So in my numerator, I have a negative divided by a negative. And in my denominator, a negative 11 minus 2 gives me a negative 13. And negative 11 plus 6, again, that is a negative number. So a negative times a negative gives me a positive. A negative times a negative gives me a positive. A positive divided by a positive. This tells me that all these values here are going to be positive values, okay? I'm going to just put lines here so I can test each piece. So this interval from negative 10 to negative 6, we're going to choose any number between negative 10 and negative 6. So I could let x be equal to negative 7. You could choose any number you want. We're just going to choose negative 7. Take negative 7 and substitute it into this expression. So I have a negative 2 that automatically gives me a negative times, I have a negative 7 plus 10 gives me a negative value. No. A negative 7 plus 10 is positive 3, divided by negative 7 minus 2 gives me negative 9. And then I have a negative 7 plus 6, which gives me a negative. So a positive times a negative is a negative. A negative times a negative is a positive. A negative divided by a positive, that gives me a negative value. Okay, do the same thing here for the interval from negative 6 to 2. Doesn't matter what number you use, but for me, 0 falls there. 0 is easy for me to use, so I'm going to let x be equal to 0. So I have a negative 2 times 0 plus 10 is a positive 10, and then 0 minus 2 is negative, and 0 plus 6 is positive. So a negative times a positive is a negative, and then a negative times a positive is a negative. A negative divided by a negative is a positive. So everything within this interval here is going to be positive. Okay, my last piece is to check this last interval there. And again, that interval is from 2 to infinity. And I can choose any number, but I'm going to let x be equal to, and I'm running out of room, but I'm going to put 5 there. Let x be equal to 5. So I have a negative 2 times a positive 5, 5 plus 10 gives me a positive 15, divided by 5 minus 2 gives me a positive 3, and 5 plus 6 gives me a positive 11. And let me go up under here. A negative times a positive is a negative, and a positive times a positive is a positive. So all these values there are going to be negative. I sure hope I did all of those signs correctly, because I did that mighty quickly. And you guys can pause, go back and think about this. This is an excellent thing about a video. You can slow this down, pause it back up if you need to. But I did all of that to ask myself, where is this function positive? It is positive from negative infinity to negative 10, and it is positive from negative 6 to 2. And remember, I can include, because this is 0, I can include 10 in that answer. So where is it greater than or equal to 0? My answer is going to be from negative infinity to negative 10. I can include negative 10 because that's where it is equal to 0. But then union, it is positive again from negative 6 to positive 2. And that is my answer. So guys, that is how we do this algebraically. Let's zoom this out so we can see it a little bit better. So there's a whole lot that we did there. But if you have any questions, do not hesitate to reach out. I will be happy to answer any questions that you have.